7 of my course on machine learning. I'll be talking about linear regression with practical example. This is a method of supervised learning. This is brought to you through my uh, YouTube channel AINEXUS and my playlist course on ML. So the learning objectives of this video are understanding linear regression, comparing regression and classification, the model equation of linear regression, what is gradient descent, evaluation metrics, real world applications, multiple linear regression, some assumptions, advantages and limitation of linear regression. So first let us talk about supervised learning, just a brush up, we have already spoken about it. So supervised learning is a machine learning paradigm in which a model is trained using labeled data. So each training example consists of input features which are called independent variables and the target variable which we want to predict. So we want to find a mapping between x and y, and so it learns from labeled data. It wants to find the relation between x and y, and it makes predictions on unseen data. There are two types of supervised learning basically. One is regression, where we predict continuous data, and then classification, where we predict categorical output. We give categorical output. So let us now go to what is linear regression. Linear regression is a machine learning algorithm, supervised machine learning algorithm, used to predict a continuous numerical value based on one or more input features. In simple words, it finds a best straight line that shows a relationship between input x and output y. Okay, so the best fit line, as we call in linear regression terms. So the types of regression problem, common applications are house price prediction, stock price prediction, sales forecasting, weather prediction, energy consumption prediction, medical cost prediction. As you look at these applications, you will find that a lot of actual applications in all domains require some of these outputs. So let us now discuss what compare regression and classification. Regression, which we are going to discuss in this video, predicts numbers, that is continuous values, while classification predicts categories, discrete values. Example here is house price, the actual price in numbers, while here it is spam detection, whether it's spam or not, category. Here another example is temperature. What is the actual temperature value? Here it could be disease, yes or no. Example here is salary, again the actual salary. Here example cat or dog. Please don't think it is only binary, as we have already discussed. It could be cat or dog or tiger also. So here the output is a number, here the output is a category. So linear regression models a relationship between an independent variable x, that is the input or predictor variable, and a dependent variable y, the output or target variable. So these terms you should be clear. Okay. So again, as we already discussed, we want to find a mapping between the independent input variable and the dependent output variable, and the best fit line you have to find out, which minimizes the prediction error. Okay, we'll come to that a little more in detail. So the heart of linear regression is fitting a straight line. So here is that equation that we have to bother about, which is y prime is equal to b0 plus b1x, where y is the predicted output, the dependent variable. b0 or b0 is the intercept, the value of y when x is equal to 0. b1 is the slope, this is the change in y for 1 unit change in x. So this is, and x is the input feature, the independent variable. So if you take this diagram, you will see that we have taken house size versus house price. The intercept or b0 value is 20 here, and the slope is the is showing you the rate of change of y with x. And this line is used to predict future values for new inputs which are not there in the data set. So first let us understand the slope. So a positive slope means as x increases, y increases. Negative slope means as y increases, as x increases, y decreases. Strength of change is Steeper slope means stronger change and flatter slope means weaker change. So example, each extra square foot increases the house price. So that's an example of this. It's actually here, it is positive slope. Again, we are taking the same example. So the model equation we have already discussed. The problem is to predict the price of a house based on its size. So house size given to us, for which we want to predict is 1600 square feet. And the model has already been trained and we've got a equation y is equal to 10 plus 0.04x, where b0 is 10. Remember, that's the intercept, and b1 is a slope 0.04. So you replace the x by this equation we got from the data set, remember? And now we are putting this 1600, we don't know the value. So we replace it in the equation and we get the price as 74 lakhs. This is how prediction is done. This is the interpretation of the prediction example. Then there are some assumptions regarding linear regression. These assumptions have to hold for the model to be valid, reliable, and interpretable. So first of all, it's called linear regression. So the relation between x and y is linear, and independent observations, that is, they are not the observations that you see are independent of each other. And the variance of errors is constant across all levels of x. Suddenly it doesn't increase or decrease. There is a term for this which is called homoscedasticity. Normally distributed errors, the errors are normally distributed with a mean of 0 and no multicollinearity, that is, independent variables are not highly correlated with each other. Then also this does not work. So with these assumptions, linear regression gives you good outcome. Now let's go to something more detailed. This is the least squares method. Find that line that minimizes the total squared error. So what you have here is, this is our, the line is given, best fit line, and the actual values are also given. So actual data points is given, the best fit line is given, and the difference between the two is called residual error. So our objective is to minimize this squared sum of squared errors. So here you have yi is the actual value, the yellow points, yi prime is the predicted value, and n is the number of data points. For all the data points you take this, and your job is to minimize this error. So what is least squares? A mathematical approach to find the line that minimizes the total squared difference between the actual and predicted values. So choose a line randomly, calculate the squared error for each point, sum all the squared errors, and adjust the line to reduce the total error. So minimum sum of squared errors will give you the best fit line. Now gradient descent is a method to find the best parameters that minimize the error. So you start with the random parameters, that is, choose random values for the intercept b0 and the slope b1. So here we have chosen random start. Then at the red dot, compute the error, calculate the error using current parameters, update the parameters, change the values of the parameters, and move in the direction that reduces the error. So you repeat this till you have got a minimum error. So this is gradient descent. And the model can be evaluated. There are different types of evaluation metrics. The first is minimum absolute error. Here it is given. I think you can understand it. This we have already discussed, mean squared error. We also have a root mean squared error. All these are similar philosophy. Then you have the R squared score, or coefficient of determination. This tells you how well the model explains the variance in the data. So what you do here is you find out whether it is 1. So interpretation guide is all the three squared, difference is lower values are better. R squared closer to 1 is better, and R squared is equal to 1 is perfect prediction. R squared is equal to 0 means model as good as predicting the mean. R squared is less than 0, then it is worse than predicting the mean. So real life examples we have already seen, but predicting the house price based on size, location, features is an example. Sales forecasting, forecasting future sales actual values based on historical data and trends. Weather prediction, predict the temperature based on humidity, pressure, wind. Student marks, predict exam scores based on study hours, attendance, past performance. Stock price based on historical market data. Energy consumption based on temperature, time and appliances. So if you see here, we have increased the number of features, X's. Okay, so then it becomes an actual real life example. So the advantage and limitation of linear regression. Advantages are it is simple, fast, easy to interpret, works well on linear data, and a good baseline model. Limitations are obviously it captures only linear relationship, it is sensitive to outliers, and we have already seen the assumption that is necessary, and its poor performance on complex non-linear data, and limited uh, when you have high dimensional data. So Python example for linear regression. We predict the house price based on the house size, square feet. We have seen this example. We are using the same example throughout the video. So you have the house size data, train linear regression model and predict. So the Python code for this is train the model. So you have the regression model and then you have X train, Y train. We have seen this before. Predict house prices. So you model dot predict and print the predict. So the key functions are linear regression that creates the regression model using the data set. Then learns the relation between the input and output, that is fit. Um, and then predicts the value for new data. So this is an example of how to use Python readily for linear regression. Then we have multiple linear regression, predicting a continuous target using multiple features. So you extend it to two or more independent variables or features. So an example is given here. Here you have b1, b2 for each of the independent variables, and that is called as a regression coefficients. Example for house price, you have area, number of bedrooms, the age of the house, distance from city center. That could all come into this equation. Uses multiple features, so you have higher predictive accuracy, and it helps to understand the impact of each feature. So there are a lot of applications for this. We have seen the house price prediction, sales forecasting, medical cost prediction, energy consumption prediction. So summary, regression predicts continuous values. Simple linear regression works with one feature. Multiple linear regression uses multiple features. And then you can evaluate using mean absolute error, mean squared error, root of mean squared error, and the R squared coefficient. So these are some of the references. These are the short answer and descriptive answers. And some problems also are given here for making you understand. And some mini projects are also given. I request you to try these. So thank you. And here we have brought this to you through our YouTube channel AINEXUS. Please do subscribe to that. It's on the playlist on course on ML. And the next video we will be talking about another important supervised learning technique, the logistic regression. This is used for classification. Thank you.